welcome to class. Today we'll be looking at probability. When we hear probability, what comes to mind? Probability means possibility. What is the possibility of this happening? What's the possibility of this occurring? Now, let's take for example, we have day and night in a day, and they ask you what is the probability of right now being a day. There are only two possible outcomes. It's either a day or night, but now it is day, which means 1 over 2. How did we get that? The formula for solving probability is number of favorable outcomes over total number of possible outcomes. So for this example I just gave, number of possible total possible outcome is 2, because it can either be day or night. It cannot be 3. We don't have day, night, or whatever. We have day and night. So total possible outcome is 2, and that is what we'll put as the denominator. Now the favorable outcome that matches the question asked is what we write as numerator. What is the probability of right now being day? It's only 1, because it can either be day or night. We don't have 2 days. You get? So 1 over total possible outcome, which is day or night, 2. Now let us put probability in action and see and understand it better. Now, now that I've written the formula for solving it, probability is number of favorable outcomes over total possible outcome. Now we're going to look at the first question. The statement states that a fair die is tossed. When we say die, we mean that thing we use for playing Ludo, dice, that we usually call dice. Good. That is a die. And we all know that that die contains numbers 1 to 6. Every good die contains from numbers 1 to 6. So let us write it out. So once you roll a die, the only possible outcomes are either you get a 1, 2, 3, 4, 5, or 6. You cannot roll a die and get 7. So when we talk about total possible outcome in this situation, it is 1 to 6, which is 1, 2, 3, 4, 5, 6. That is our total possible outcome. Now the question 1 says, what is the probability of rolling a 3? Now, like I said, the formula is number of favorable outcomes over total possible outcome. How possible is it that you can roll a 3 when you roll a die? Now the question we ask ourselves is, how many 3s are in this die? Just 1. So the probability of getting a 3, because we have just 1 3 here, is going to be 1 over total possible outcome. We now calculate the total possible outcome that we can get when we roll a die. We can either get 1 or 2 or 3, 4, 5, or 6. So the total possible outcome is 6. 1 over 6. Do you understand that? Good. That is the answer for number 1. Now let's go back to number 2. Number 2 states, what is the probability of rolling more than 4? Now this is the place you have to think and look at the die one more time. What is the probability of rolling more than 4? We know that the denominator remains 6, because the total possible outcome is 6. The denominator remains 6. Now we come to the numerator. The question is, what is the probability of rolling more than 4? How many numbers in this die are more than 4? Let us check. 1 is less than 4. 2 is less than 4, we don't pick it. 3 is less than 4, we don't pick it. 4 is equal to 4 but not more than 4. The question states, what is the probability of rolling more than 4? So, we pick the numbers that are more than 4, which is 5 and 6. How many numbers do we have? 2. So, the number of favorable outcomes is 2. So, we put 2 on top. I don't know if you got that. We have 2 numbers that are more than 4, and that is the question. What is the probability of rolling more than 4? The probability of rolling more than 4 is that I can either roll a 5 or 6, which is 2 numbers. That is why we have the numerator as 2 over 6. We divide it further, we have 1 over 3, because 2 divides itself 1, 2 divides 6, 3. So the answer to number 2 is 1 over 3. I want to believe that you're understanding it and you're getting there. Very good. Let's solve the third question. What is the probability of rolling less than 5? I want to believe that you'll be able to solve this question based on the explanation. So if you want to try out, pause this video and try it out. Then play the video and check yourself. But let's go. Total number of possible outcomes remains 6. Now the question is, what is the probability of rolling less than 5? Now this time around, we are going to consider numbers that are less than 5. If we get a 1, it is less than 5, 1. We get a 2, it is less than 5, 2. We get a 3, it is less than 5. We get a 4, it is less than 5. If we get a 5, it is not less than 4, than 5. And if we get a 6, it's not less than 5. So how many numbers are less than 5 on a die? 1, 2, 3, 4. We have 4 numbers that are less than 5. So the probability of rolling a number that is less than 5 is 4 over the total number possible to get on a die. Which, if we divide further, 2 here, 2, and 2 here, 3. The answer is 2 over 3. Did you get that? You did. Kudos. So we have 2 over 3. The next question says, what is the probability of rolling an even number? Very good. What is the probability of rolling an even number? We know that our denominator remains 6 because that is the total possible outcome. Now the question is, what is the probability of rolling an even number? Look at this. We know that even numbers are numbers that can be divided by 2. So let us pick out all the numbers that can be divided by 2. 1 cannot be divided by 2. 2 can be divided by 2, so it's an even number. 3 cannot be divided by 2. We don't pick it. 4 can be divided by 2. 5 cannot be divided by 2. 6 can be divided by 2. So the probability of rolling an even number is 1, 2, 3. So that is what we put on top. 3 over 6. Divide further, 1, 2. That is 1 over 2. Did you get that? Very good. 1 over 2. Now for the final question, I want you to pause this video, solve it, drop the answer in the comment section, and watch the rest of the video. Let me know if you were able to get it. But let me first of all explain to you that prime numbers are numbers that can be divided by only itself and 1. Prime numbers have just 2 factors, 1 and itself. No other number can divide a prime number. Now the question states, what is the probability of rolling an even prime number? Not any prime number, even prime number. So let us solve this. The denominator remains 6. Now we are going to solve for the numerator. What is the probability of rolling an even prime number? First of all, we have to pick out the prime numbers. Then we check which of the prime numbers is an even number, which is 2 is a prime number, 3 is a prime number, 4 is not a prime number because it can be divided by 2, 5 is a prime number, 6 is not a prime number because it has 2 other factors, which is 2 and 3. Now, we have picked out the prime numbers. The question states, what is the probability of rolling an even prime number? Not just any prime number, an even prime number. 2 is an even number, so we mark it. 3 is a prime number, but it's not an even number, so we don't choose it. 5 is a prime number, but not an even number, so we don't choose it. So how many favorable outcomes do we have here? Or how many numbers answers our question? It's only this number 2, which is 1. So the answer is 1/6. Did you get that? In the next class, we'll be looking at how to solve when probability contains or, and also when probability contains and. There are different methods of solving them, or and statements. Thank you very much. Join us in the next class.